Hi there and welcome back to Triplicate, home of interesting electronics, and today we're going to hopefully finish off the cat feeder, the automatic cat feeder. Okay, so let's finally set it up so it is timing hours, not minutes. So one revolution is 50 hours times 3600 equals that many seconds times 1000 equals that many milliseconds, and there are 4096 steps per revolution, so one step is that divided by 4096 equals 43945, as near as we care. 43945. 43945. And we are going to put that in as hours, and that in as minutes, and comment the minutes out. Behave. And I'm going to now turn the camera on and we're going to watch what it does. Okay, so the first thing I'm going to do is put these lids back down so they're not in the way. It's not fast. However, you're only setting it up once in a while, so you can live with it. It's just that I'm not sure the stepper motor will actually go much faster than this. I'm rambling because I'm waiting for this to come round. So can I come down? That's one of them. Change hands on the camera. Talk amongst yourselves. Go down, it is. Motor it on a bit more so it stays down. Right, so shall we see? Now it's one step every about 44 seconds now. So shall we change this code, compile it, okay, it's doing it. What are we doing? It thinks we're there. Is anything gonna happen? Oh yeah. So in about another 20 seconds or so, the other one should blink. Yep, So we've replaced, I can turn this over, causing mayhem, the original clockwork mechanism with 2 stepper motors driven by our trusty Arduino and 2 cheap off eBay stepper motor driver boards, and that's going. So if we press the set button, you can see the knobs are rotating and all the lights are flashing. Same for the other side. And if we look at this long enough, oh, there we go. Yep, so that's turn this knob on 1 tick, and that's set up to time, so the whole way around is 48 hours. So now we want to work on getting the electronics into the case here. And to aid this, I have got a Chinese made Uno copy for £5 or something ridiculous like that, which is going to become the permanent processor board in here. So the first job is to connect this up and check we can get the code in it and get it working. Okay, so the first thing, let's plug it in to the USB and see if the Arduino software recognises it. I'll get the USB out, one-handed. Right, so in we go. It's lit up and something's happening. So if we go around to the editor, it seems to think it's okay. So shall we try and program in the cat feeder code? Check if current board is currently available. Yeah. Okay, so that's my genuine Uno, and this is now plugged to the Chinese Uno. We plug it in, and we just needed to do a bit of fiddling here. So when I looked at this, and I did this off camera, unfortunately it just said board at COM4, so I selected that, and hang on, if I click that, yes, this came up and asked me to select what type it is, hit OK, and it's happy, it's found it. So it's not quite the same, it's sort of slightly different route to go via these generic boards. So shall we try firing the code down to it? And we'll see if it works. Turn the power off. Well, if we... Oh, where am I looking? Come on. There we go. So that seems to work. Excellent, excellent, excellent. So I will power it all off again. because now we need somehow to get this little lot in there. And preferably get that on the bottom. So I shall ponder that. Now, up to now I haven't done anything that would prevent me switching it back to the way it was, but I'm not going to do that. So I might chop these 3 pillars off, so that board will go there, and somehow I've got to get the power in. So I shall ponder that and bring you back. Okay, so this actually slides down and fits nicely just down in there without chopping anything. So this is the bottom, which has a big hole in it for don't know, the original clock mechanism somehow to stick up through. I think so you could change the battery. Didn't need to set the clock. Anyway, it is what it is. So I have cut a slot in there and a slot in there rather crudely using cutters, and sorry about the camera shake. That now fits nicely in there, and that holds, those 2 slots hold the 2 circuit boards in place, and that's that. Might put a few little bits of some kind of sticky back foam in there just to stop it rattling around, but that is good. So now we have to try and get power into it. Now, I don't think that I can be cheeky here and camera shake again. Put a lead in there. The stepper motor is going to be in the way. So plan A is to hack that plug off, find the 5 volts and 0 volts wires and solder them on the back of here. Actually, that's plan B. I might try and hack the plastic casing off, because I'm sure the plug only goes back to about there, so it's like that. There, well clearing the stepper motor, so then the wire could be bent out of the way. So I will try and carefully cut the back of the plug off so we can bend it round. Then I shall drill a hole in the side, possibly, yeah, possibly in that side, probably in that side, and put some kind of a cable grip in there, and we're good. Okay, and there's me giving up on it before I'd actually even tried, so here we are. It all goes in. I've just pulled this out of the big hole in the bottom for now, because I haven't drilled a hole in the side yet. So if we pull this out again, you can see it. It's bent slightly against there, but not a problem. And what's more, it actually now seems to hold the boards in quite firmly. So we're not trying to make a consumer product here, we're trying to have a bit of fun and resurrect something that didn't work terribly well and make it work better. So I will now drill a hole in the side and try and find some sort of clamp that I can clamp over there and actually get the plug through. And I'll bring you back. Okay, couldn't find any cable glands or anything that would suit, so I've ordered some of that type, and the problem is with the plug on, I've got to find something I can actually push the plug through, big enough hole to get that through and still clamp down on there. Now these guys, you put the cable in the slot and put that on and then push it into the hole, so you don't have to get the plug through. So I propose to drill a hole here and then open it into a slot so we can get the cable gland and the cable in, and then that goes down. Hang on, point at what you're talking about. That goes down on top and fills in the bottom of the hole, hopefully. So shall we put you in the stand and drill a hole? Okay, I realise we're not at the best angle for you guys seeing, however, got to be at a decent angle for me to drill it and hold it firm. So we drill a pilot hole. Okie dokie. So now we'll drill the main hole with step cutter, and we want, for now I'm going to go with 8mm, and we might have to drill it out when we get the cable glands. Can you see that's good? That is 8. Is that 8? I've got a useful thing here, which is just a plate with a bunch of holes drilled in, labelled. I use it for finding what drills are. That 8. That's 8. We'll leave that at that for now. So we want to turn that into a slot. Again, can I sit this on end? Yes, I'll try to sit this on end. Is that going to work? Yeah. So I am going to do some precision measuring and marking here. There and there. So we have a Dremel with a cutting disc on, and I'm going to use that to cut those out. So firstly I need to go over here and plug her in. Right, nasty noise I'm afraid. That was easy. Oh, stop it. Stop it, stop it, stop it. So, let's smell burning plastic now. There's some rubbish. If I put this back on, come on. I know you want to. As you can see, that probably needs a bit cutting out at the bottom there, but I'll leave it for now because I'll wait for the cable gland and see how it fits together with that before I start doing any more cutting. And let us see if we get this. To go together. In the meantime, that's good. So what all I'm going to do now is put a big tie wrap behind there to stop it pulling out. So, shall we do what we need to do? What do we need to do? Well, we need to now connect the 5 volts to the motors to the 5 volts going into the Arduino. How do I do that? We'll take the lid off, and also I was going to put a, what's this, 470 microfarad capacitor across the supply, just to help the power supply out when the motor's running, just to provide a bit of extra oomph to turn the motor. So I think I need to try and zoom you in. Wrong way again, as ever. Right. So, a screwdriver to use as a pointer. This 3-way bus here is the 5 volts to the motors. That purple wire goes to that motor driver, this purple wire goes to this motor driver, and this twisted pair goes off to the external power supply. And these red wires are the 5 volts from the USB coming up from the Arduino board. So what I think I need to do is take these two off and make a connection between there and there. I might even use a bit of that purple wire there. So we don't need this black wire anymore. Alright, what have I done? Right, going to try and make this at a better angle. Okay, intermission, wadded a piece of cleaning cloth in there to try and wedge it in place. So this is through hole plated boards. You have to get the top and the bottom hot at the same time. Pull the wire out. Oh, that's come out. But you do need to get the bottom hot. Right, I'm not pulling the other one out. I'm gonna cut it. Are we still on camera? Yeah. About there. So let's get rid of that. I'm going to try and strip a bit of this off. Obviously my normal wire strippers won't fit in there. I know people, can we see that good? You do strip wire this way all the time. I'm not one of them. There we go. Yeah, are we still on camera? Yeah, we can see that. Yeah. So when you do it that way, you stretch the insulation as you're pulling it, and then when you heat it up it shrinks back to where it was, but we've got plenty of wire, so it's not a problem. Right, so you're looking down from the back and I'm looking from the front, and push comes to shove, I think I need to see what I'm doing. A magnifier there. Okay, here we go. Can I move that out of the way, that out of the way, and that out of the way, so that, I'll move my fingers out of the way. That little hole there is what I'm trying to get this wire in. I think I might put it on the top like that and solder it down. Here goes. And we're out of shot, sort of. Well, we can get a good connection here, if not a good shot. Right, it's down. Okay, so plan C or D, it's going to go like that and come out at the end there. And quite how I'm going to mount it, I don't know. So, as I say, this is the same as this, so we know these are plus and minus. We've got to get it right. So plus 5 is that way. There, right, yeah. Are we in the camera shot? Plus 5 is towards the capacitor as it is now. So, that's plus. Come on. And minus is there. It's round like that. Probably. So that's it, and these two guys just need to poke slightly below the level of the capacitor. Out there, and there. Gonna have a couple of little bits of insulation on it. Just in case, you know what I mean? Which I should have done before I bent it. And about that, it should. Alright, let's have a look. So it is definitely, maybe you can read that, +5 it says there, which is near the edge of the board. +5 near the edge of the board. And yeah, +5, that's the positive, because that's got a negative on it. Near the edge of the board. And I'm going to get these. A couple of holes. How about that? Okay, it's the next morning and the memory card on the camera filled up last night and I hadn't noticed, so it was cut off in my prime. Anyway, here is the capacitor on the back of the board. I will attempt to zoom in so you can have a look at that. The camera focusing, yeah. Okay, so that'll keep our power supply up to scratch with sudden current draws from the motors. So let us now zoom out again. Connect. Processor board back up again. Put the base on. Oh, I haven't put a tire up on there. I shall just be careful till the proper cable clamp arrives. Put that there. I believe that is the screw for it. Well, that's got the screwdriver that fits it. Near enough. Okay, so we have here a USB connected to a socket that stays on all night. Now we have here a cable, which is knotted up with everything as ever. So let's power it up. Can we see that? There we go, so both sides are going round on the set button, so we're assuming they're working. So we are going to set this to 24 hours and 48 hours. Okay, so we're going to use our Garmin for timing now, running watch, and we're going to set one of these to 48 hours and one to 24, and then we're going to leave them for a couple of days and we'll check every late morning to see how it's doing. So here we go. Oh, those buttons. I think I'm going to change those buttons out. Non-terrible ones. That's a hair under 48, never mind. And this one, to 24, and it's 11:15, so 11:15 tomorrow. That one should open. 11:15 Thursday, it's Tuesday now, that one should open. Okay, so that side's hinged up, the 24-hour side at 10:44, which is, I think, maybe half an hour short of the 24 hours we set it to. Let me see, it's hinged up, but I think it's probably near enough. And the other side, which we set to 48 hours, is showing just under 24. So tomorrow, same time, same place, we'll check that one comes up at about the same time. Okay, so there we go, the other side's flipped up at 9:54. So I think we're going to call that a success. The only thing I might do is, and I'm going to have to go back into the previous video, I think it's probably running a smidgen fast. It may be that cheap Arduino copy, the internal clock isn't as accurate as it might be. So I might tweak that, but apart from that, I think we're going to call that a success. So, if you like the channel, please subscribe, give us a thumbs up if you've got a hungry cat, leave a comment if you've got anything to say, and from now, that's goodbye from Triplicate, home of interesting electronics. Goodbye. And I forgot to mention, the cable glands came in. So, there we are. Finished. Okay, see ya.